if we can just jump right into it, Iain. It's been a while. We saw you last year in Austin. You give multiple presentations, and I guess from my perspective, being from T-Mobile and looking at different things that are happening in the industry, we heard 5G was a 2020 story. What gives, and why is it now a 2017, 2018 story?
Good question. By the way, I'll tell you, these guys sent me like a list of like 50 questions that we were going to ask. So it's like studying for an exam. IMT 2020 was always going to be 2020 because that was when the standard would be ready, and they tried to get everything in that standard. And what they've done is, and I say they, the industry, you guys, right, is everybody realized that there was going to be some carriers who were going to brand things like gigabit LTE, which is release 14. They were going to brand that as 5G to get on the bandwagon and get some marketing push. So what they've done is they've actually pulled part of the 5G spec, that new radio piece, forward. And they scrambled and got it all finished up in December of 17. So you'll have the equipment, I think it's like 6-9 months from now. So any radio you bolt onto a tower this year will be 5G. But it's only the radio piece, so it still connects to an LTE network. Now, from your point of view, from the evaluation point of view, this does not mean that all that spending that was going to happen in 2020 suddenly rushes forward to 2018. It means that parts of that for the radio are pulled forward. But the next phase of it, this is called phase 1, by the way. Phase 2 is we actually change the packet core ready for 5G as well. So it's faster and all that. So they've kind of split the effort. And as previous speaker Andrew was saying, that Jeffrey Andrews, it was for the Koreans because they were gonna show something at the Olympics called 5G. It doesn't matter if it was a standard or not. Skiers are going to be going down that hill with cameras on their heads, and you'll see the crash in real time. So.
Well, that's a good intro. So, talking about the crash in real time, you've previously said it'll be a $200 to $250 billion spend plus, at least in the U.S.
Yeah.
Can you elaborate a little more? Do you see that changing?
No, it's going up right now. Actually, I just worked this out for last week. It's hard to say it's 100 billion or 250 billion, right? Because then people say, well, how much do people spend now, right? How much do the carriers spend? And you guys spend quite a bit of money, right? So what I did actually, but worked it backward, and I said, okay, let's look at all the spending between now and 2026 on 5G, okay? And include in that all the pieces of things that have to happen in 4G to get ready for 5G. So if you're putting in a new macro cell today, you're putting in fiber backhaul ready for 5G. You won't use it yet, but it's going to be sitting there. So include things like that. And what it works out at is $2 in cost for every single subscriber in the United States for 10 years. So start today and charge everybody an extra $2 for the next 10 years, and you'll pay for it except for the spectrum. It does not include the spectrum cost. So ARPU is $58 on average, right?
And going down.
Right, yeah. See, this is the problem now. We're going down, right? So now we've got a dropping ARPU, and I'm telling you to put I'm telling you to make that $58, $60. So call it 3.5%. But now you got to account for that drop. So yeah, that's how much.
That seems like it's a challenge for the carriers when you're looking at it. And I guess the next question that I have for you is, have you seen business cases out there that support this spend? I mean, or is it still, we build it, we will come?
It is, yes, it's build it will come, and yes, there's some pretty decent business cases. Some are going to take longer than others. The first one is, okay, so think about the whole telecom pie here of your spending as a household. And in my case, $74 a month goes to Time Warner Cable for internet access. About another $60 used to go to cable, used to go to TV. It's gone. Now we've got a Sling TV, right? So there's $40 there. Well, you guys, you bought that layer 3 TV. You give me that service. Now you can have some of that revenue for that. And then you start putting in a fixed wireless service, millimeter wave into my home. It's goodbye cable guys, hello wireless guys. So there's a shift in revenue away from the cable guys into the wireless that's new. It's new for the wireless guys, but it's not new for the industry as a whole, right? Then there's things like Verizon bought AOL, AOL and Yahoo, right, for their advertising platforms. So you start putting more content in there, now layer on advertising. So you start taking some of Google's ad spend away, right? So there's things like this and more broadband. You know, I think you can charge a little bit more for it, a few bucks, because you're getting 4K TV and on a per meg basis, it's horrible, but overall it's more. So I think there are things like that we can do. But you'll notice I didn't mention Internet of Things. River of pennies. Lots and lots and lots of pennies. Be great. You know, I mean, I keep picking on you. I'm going to pick on you in a minute. You guys.
That's what he's counting on.
Yeah. T-Mobile announced your IoT pricing last week, I think, and it's like $6 a year base level service. That's 50 cents a month. I mean, great, get 1 million devices. Congratulations, you know, $500,000 a month. Yeah, it doesn't move a needle here. When I'm talking about $2 in ARPU for every man, woman, and child in this, IoT takes a long time to move the needle. So, right.
Gary, I'll turn it over to you.
So basically what I heard earlier from Jeff was that the only way this 5G stuff works is if you're getting a phone call, you got to run outside because it won't penetrate anything if it's on millimeter wave. So how the hell do you get in the building if you're trying to do 5G?
Yeah, it's actually even worse than that because millimeter wave, when you hold the phone, your hand, the water in your hand actually blocks the signal. You think I'm joking? I'm serious. So it's almost like you get that phone call, you know, turn around, you know, or no, I'm serious. This is really, I'm going to digress and I'm going to answer your question a little bit. In the phone today are about 8 antennas. And if you rip apart an iPhone, a new one, if you want to, and then take one of the first generation ones, they're not that different inside, right? The first generation still had Wi-Fi and it had 850 megahertz and PCS band. We've added a few more bands, but not that much, right? They're talking about 24 antennas in an iPhone for millimeter wave. So while you're holding it, the top of the phone, if it's exposed, would be the antenna array. And then if you do that, you know, now it's got to go through your head. I mean, it's the engineering is incredible. So he talked about adding millimeter wave to a phone. He said somewhere between 2019 and never. I actually think it's around 2020 because you've actually got to fundamentally redesign everything in that phone, including the screen, because the screen will probably have antennas on the front of it. So, because you got to pack them all in. I mean, if you're holding the phone like that, the screen's exposed, right? So the in-building question is really good because already today we have problems with Sprint has a lot of problems with 2.5 gig signals bouncing off. CBRS 3.5 gig will not go through a window with tint on it, as he was saying. So what we're ending up with is, well, you have a cell site outside and you have building coverage inside. So put small cells inside the buildings. And we were talking about this at lunch, is one of the things is now is if I can't put small cells down the street because the city of Austin zoning won't let me do it and nobody can agree on what they're going to let me do, put it inside the building, right? And then hang small cells off the outside of the building. The building owner will let you do it. The hotel gets good coverage. Everybody's happy. So there's almost like an inside-out strategy going on right now to do that. Verizon did a trial up in Chicago. They took 4 9-block areas, and in the middle of each area, there was a commercial building they lit up with small cells. Then they ran dark fiber out from there to all the remote radio heads on the surrounding area. They decommissioned all but 2 macro towers. So you can do it. And all you've got to deal with is commercial building owners, landlords, right? Not the city and Harris County and other wonderful people like you.
So Ian, are you saying that this proliferation of small cells that we see, or I was expecting they'd be hanging off of light poles downtown, maybe not really how we'll see it?
If you can do it today, the planning cycle for a new macro tower is about 2.5 years, right? So anything that's built in 18 was planned in 16, pretty much. Lo and behold, putting up a small cell takes about 2 years right now, and it's coming down slowly. But the idea with a small cell was it'd be 3 months, right? And literally zoning, planning, 3 months. Guy runs out one afternoon and nails it onto a pole or something. It's 2 years. So from my perspective, this is great because forecasting small cell deployments, all I've got to do is look at all the planning and zoning applications that started in 2016, 2017. This thing crackles by
Yeah, it sure does.
I was like,
I thought I was going to burn my foot there for a minute.
It's so yeah, it's the challenge of the industry is get that 2 years down to something manageable. You know, start with let's get it down to 18 months and a year, and it's going to take. I mean, the feds are working on it, the states are working on it, but it's not a technology problem. We got all the technology to do this. It's getting the right to nail something to a pole or drop a pole in. Yeah.
So same old thing as usual, regulation will slow it down a lot.
Yeah.
Right?
Yeah.
So when I read today my company's press that says we're rolling out 5G in 23 cities,
Yeah.
Austin's one of them,
Yeah.
this year,
Yeah.
based on what you're saying, it's probably not real 5G. Is that right?
Did you just say that?
I did.
You say
I,
that?
I don't need to work a lot longer. I'm a retired politician.
Well, back before, no, they're going to roll out 5G service. It is 5G standard because it's that 5G new radio, right? So yeah, you're going to have it. It's going to look a lot like gigabit LTE. I mean, we've got to remember the back end of this thing is LTE. So the front end may be really, really fast, but it still hits a back end that looks a lot like LTE. So it'll do some things really fast. We won't have the low latency, the 1 millisecond. That will not happen until we get the new core. But boy, you'll get some speeds out of it. I mean, as a user, consumer, you'll see it depending on the device you've got. So yeah.
So the other thing I read is when
I rescued you pretty well on that one,
you
didn't
did.
I? Yeah.
I appreciate it. I need all the help I can get. So you know, the other thing is I read, particularly when I don't bother much with T-Mobile, but I do read a fair amount.
Just keep that thought.
about Verizon, and Verizon's model and AT&T's model in terms of how we plan to deploy small cells seems to be different, right? What I read is that Verizon's signed a huge contract for lots and lots of fiber.
Yeah.
And plan to connect those small cells with fiber.
Yeah.
Whereas what I read about AT&T is we don't plan to connect all those small cells with fiber. What's really the story?
Yeah. So Verizon has the fiber one policy, right? Is you can't have too much fiber, and I have to agree with them. And everything ends up in fiber. You need fiber at some point. So even if I'm going to put small cells down the street outside, somewhere along that point there's a fiber connection, right? We're not doing wireless all over the place here. It's got to, so I may have 1 in 5 need fiber, but I'm still going to need fiber. I still need fiber into my macro cells, into the buildings, et cetera, et cetera. So people like Externet, Crown Castle, Externet's overbuilt in New York, Las Vegas, and LA. They're putting like 800 strands in on every corner of Manhattan, right? We don't need it today, but the goal is when somebody says, I need to put a cell right there, a 250 meter or 100 meter radius small cell right there, they say, we got the fiber. It's been there 5 years. If you're going to dig a hole, you may as well put 800 strands in versus 40 strands, right? So it's always it will happen in the end. But go back to my 2-year planning here, right? If I've got planning permission suddenly to put a small cell in, and I can't get fiber in there, this is what you guys do. You go, hey, get the small cell in, wirelessly connect it, and we'll get fiber in when we dig up the street in a year's time or 18 months' time. So what eventually that's going to need fiber. But right now, just get it in, get it wirelessly connected, wireless backhauled. Let's be able to use it. Don't let's sit there and go, oh, got to wait for the fiber now, because getting everything to coincide, and that's really the difference in the two approaches. The Corning deal that Verizon has for fiber is really a lot like Apple and Samsung locking in screens. It's making sure that I've got the supply of fiber when I want it. And frankly, they've already written the check actually for that deal. You know that? Somebody wrote a $1 billion check and handed it over, and then they got a tax cut that paid for it.
Good deal if you're a fiber company, huh?
It's a great deal if you're Corning.
Yeah.
Yeah.
Right. I would kind of migrate back
You got a question in the back there.
Yeah.
Are you?
Rosella? No, I don't mind. You can ask all the questions you want. She sets my value in Missouri, so she can do whatever she wants.
So if I have I can't get any other access through the city ordinances, so I put the cell up on top of this building. Am I better off than having a fiber route into the building to have other small cells inside the building?
Yeah. Yeah, so any of the commercial buildings around here have fiber running into the building already for all the workers in there, that desk Ethernet and all that stuff, right? So what you're doing is tapping into that to put small cells throughout the building, provide coverage inside, and 70% of mobile data is used inside a building, in a home or a commercial building. You don't use that much data driving home because you're not watching, House of Cards driving home, hopefully. But then you can hang them off the side of the building and run the fiber down through inside the building and use that link as well. That's what they do. Yeah.
I was going to say, you mentioned getting in commercial buildings. Is there a solution for residential? Can customers get small cells to put inside their homes, or how do they?
Yeah, so you have it today. It's called Wi-Fi. At various times, there's been different. You guys had a 3G microcell. You called it. It was a small femto cell. Use the backhaul. Use your cable modem connection or whatever, but had had 3G inside your home. You've had the Wi-Fi. You do the Wi-Fi stuff. T-Mobile does, and then Sprint.
Who?
The guys in Kansas City that you were trying to buy and then you couldn't do a deal with them. Somebody came to their senses and realized they were not worth more than $3.50. There's no Sprint. Are there Sprint guys here today? Yeah. You knew it was coming. No, Sprint has that Magic Box. Is that what it's called? Magic Touch? Magic Box? Magic Box. So what that is actually is a little LTE radio, and it takes the signal that's available and it just amplifies it massively in your house. So they hang those things off everything they can to get their signal in more places because they don't have the macro towers to do it, basically. So yeah. There are places like that, but within 5G, there's no talk of taking more 5G signal into the home. Okay, the one of the problems is you've got this. What am I going to build into my iPhone, my tablet, whatever it is? When you think of all the Wi-Fi stuff in your home, there's a lot, right? TVs, Apple TVs, etc., etc. So most of the 5G stuff to the home assumes that the connection to the device will be Wi-Fi. So when they talk about millimeter wave for fixed wireless to the home, there's actually a panel that sits on a window, gets the 5G signal, and then converts it into Wi-Fi for the home. So, okay. Keeps all the Wi-Fi guys happy.
So do you have anything else, or are you done? All right, let's talk about latency a bit, right? Because latency is a big deal with 5G, and it's supposedly what will allow many of these innovations like, cars that drive themselves and all that sort of stuff. And hand in hand with that, and you just kind of answered all at once, talk about putting a fair amount of equipment on the edge at cell sites, right?
Yeah.
So could you help us with that?
Yeah. So today, the latency in an LTE network is about 60 to 70 milliseconds. So if you take your speedtest.net and do that little test, you'll see it. Occasionally, you'll see 40 milliseconds, this type of stuff, but not unusual to see 60 or 70 milliseconds. So the best example is, the one I always love is remote surgery, right? 67, and there's jitter as well. So you get jitter of like 3.5, 4 milliseconds, right? So it's kind of like having a surgeon who's had a few drinks and is doing this, as he's operating on you. And then he may just stop operating, halfway through, right? That's the equivalent of using LTE. Yeah. And I always ask people, who wants to be the first, who wants to be the first remote surgery patient? Nobody ever has put their hand up. I've been at conferences where they've been, we're going to have remote surgery, we can do this. I'm like, so you're going to be first then, right? Oh, no. So what's going to happen is some poor sucker's going to have a car accident, right? And they're going to be in like West Texas having this car accident. We rush to hospital like, oh my gosh, we need a heart surgeon. And there's no one there, but they've got one of these machines, and the guy will be in Dallas, and then they do remote surgery on this guy, and he wakes up and says, congratulations, you're the world's first remote surgery patient. And if he doesn't wake up, he's not the first. So if you want to do remote surgery, you want latency of about a millisecond or 2, right? Maybe 3. You don't want any jitter. You don't want any of this, right? Think of it as a shaky hand. Well, the speed of light is a real problem here because over a fiber, and I cannot remember what it is, but it's like 2 milliseconds. No, is it half a millisecond per kilometer of fiber? That's what the speed of light is, right? So the longer it is, light takes a certain amount of time to move. We can't change the laws of physics. So what we want to do instead is move the processing for that to the edge of the network. So if a good example is Netflix, right? If you put the Netflix server right next to the base station, the tower, then you'll get a response like this, right? If you put the Netflix server over in the internet, it's got to go all the way through the wireless network and all the way out the back into the internet, come all the way back. It takes much longer to start streaming. So if we move stuff to the edge, then that's good. Now, that does a couple of things. One is we move equipment to the bottom of the cell tower or in a building like this for feed small cells. So the equipment, there'll be cost to that. It will be storage. It will be processing. There are companies doing this today. Crown Castle's already starting to do this. There's a company called Edge Micro. There's actually building mini data centers to go in the bottom of cell towers. It's worth looking at. So that's what it does. But the problem is, who decides what applications go at the edge and what go in the core? Some applications are going to be in both places, right? And that architecture is not that fluid right now. The industry is working on that, and that's when you have to have automation in the network and things like this. But it can also be, you and I were talking about, driving the kids up to Dallas and then watching movies in the car, and that you stream it on Netflix to the car. Well, maybe you have a little server in the car that when you hit a major city, it gets 1 gig service and caches a bunch of content. Then you hit the highway and they can still watch it and nobody knows any different. That's a lot easier than actually building a 1 gig service out in West Texas. Things like that. So latency is a big deal.
So what does that mean with regard to the equipment? Is that always at a macro cell and you don't do that at small cells, or do you see it both places?
Both places, yeah. So the macro towers are really nice because at the bottom of them there's all this land that the tower companies own. And if you ever go look at a macro tower these days, most of the land at the bottom is empty because you guys used to have all those porta cabins there when the radios were like this big. Well, now the radios are this big and they're on the top of the tower. And you usually at the bottom of a macro tower, there's all these empty pads. It's got great security. There's a big fence around it. It's got power. It's got backup power. It's got fiber. And lo and behold, macro towers are where the people are. 'Cause that's why it's there, right? So put stuff there. You're putting the stuff closer to the people, lower latency. Now, if we build small cells out in this building, right? No point putting the edge over at the macro. We want to put the edge processing down here in the basement, right? So yes, it will be in the buildings. It'll be in the edge of it'll be in the macro site. It'll be the old central offices. You know what central office is. He doesn't know what.
Yeah, I know. I argued with you about this once before.
Yeah. Yeah, and I said central offices are in really good places, and you said no, they're not, and I said yeah, but we're going to repurpose them and call them data centers.
And I said no, we're not.
And they said no, we're not. And lo and behold, yes, you are. No. By the way, a central office is where the old telecom equipment used to go. Telephone equipment.
Thank you, Ian. We need to educate him all we can. No, I think the issue there, I got to clear that up because you just created a big problem for me. When you talk about a data center and you talk about a central office building, the central office building could be a 5-story building, right? Pretty old technology. And when you say put a data center in that building, what you're really talking about is putting the capability to house computerized type equipment in a very small area on one floor, probably. You agree? I hope.
Yes. Yeah, I do agree. Yeah. It's an AT&T building. It's a building with AT&T on the outside with telephone stuff in it. There you go.
There you go. All right.
On
Yeah.
one floor.
Yeah.
One part of one floor.
One part of one floor. Yeah. Yeah. In fact, when you see a very little bit of this now, and what you see is, in order to get adequate cooling and power in there, they have to focus it in a very small area, and they'll take these big sheets of plastic so they can concentrate the airflow through it.
Yeah.
It wouldn't work if you're trying to do the whole
Yeah.
floor or the whole building.
floors yeah.
Yeah, I think I've covered myself enough on that now.
So, Gary, you're saying, so it's only that one floor that's worth $1,000 a square foot? Is that
No, it's not one floor. It's about a quarter or less of a floor.
So actually, you know, joking aside, this is worth exploring, right? So there's a company, as clients of mine, they build out buildings. They build small cells in buildings. And they did one in Houston. I may have told you about this last year, but they've got a mini data center in the bottom of the building to house all the basebands for the radios in the building. Verizon came to them and said, I need some space in that for stuff, edge stuff, right? So they were paying $2,500 a month, I believe it was. I know the number's 2,500. I don't think it's 2,500 square feet. It's $2,500. 18 months later, Verizon's paying $15,000. Not because the rates went up, but because they took more and more space. So you look at this data center now they've built, it looks like a data center with a bit of radio in it. It looks like a data center. There's that much stuff going towards the edge. So we are at the point now where, you know, you start pushing more and more things out there that, you know, the data center, it is a data center, right? You may need the air conditioning and all of that floor because there's enough things to go out there. The people who love this idea, there's three of them: Amazon Web Services, Microsoft Azure, and Google Cloud. Because right now, everything they have is in the cloud, right? They are starting to move some of that processing to the edge. Well, the edge of where? The mobile network. So that space now, you could have in a building like this, literally in a couple of years, Amazon Web Services in the building hosting applications for you. Go look at their Greengrass initiative. That's what it's all about. And they're doing it now. So,
Since we're talking about the edge, let's talk about the equipment that has been on the edge up to now, and what's going in now, what will go in the future. The big change from specialized computing equipment that designed specifically to switch calls and such to, you know, the popular term now is white box computers. Can you talk about that a little bit?
Yeah, so instead of buying it from Nokia and Ericsson and then jacking up the prices, it's now cheap. Yeah, yeah. That's why the OEMs are panicking. No, we've been talking about this for a while where a radio, let's take a radio, instead of putting it on a specialized piece of hardware, radio and baseband, you actually it's just software. You put it on a processor, you put it on a PC actually. There's a company that did this about 4 years ago. And they showed it to the industry, and the industry went, the carriers all went, yay, great! And Ericsson, Nokia, Alcatel-Lucent, Huawei, ZTE, etc. said, oh, it'll never work. What a surprise. Now, fast forward, that's exactly what we're starting to do. So the big push, actually, a lot of it comes from Intel. Intel did a horrible job in 3G, and 4G they missed completely. They are not going to miss in 5G. So they got architectures. They actually announced one this morning, a testing platform for 5G new radio. But they've got blades running their processors, specialized processors. You slot into a rack, and that is your radio or that is your baseband. And you can configure it. You can move it. It's virtualized. You could buy it from Dell, HP, etc. I was actually at Nokia the week before Christmas and in Finland, and they spoke for 2 days about cloud, virtualization, white box, open, friendly, management, intelligence, all the things you do. They're trying to look like a cloud company that does wireless. Ericsson's getting there. They're not there yet. Huawei hasn't got there yet. You guys a lot of your RFPs now require open platform, right?
Yep.
And the stuff you're doing is same thing as well.
And that's a good comment, just on the supplier side, because you talked about Huawei
Yeah.
and ZTE and the other major carriers that are European based. How do you see that impacting the U.S. and do you see struggles with the different manufacturers over the 5G build out?
Do you mean okay? So you mentioned 2 Chinese vendors there. Do you mean the Chinese vendors coming to the US?
Correct.
They'll never happen. Never happen.
And how do you see the health of the Nokias and the Ericssons trying to?
Well, Ericsson's having they had to borrow $370 million to fund their 5G development. What does that tell you? Yeah, that's pretty bad. The best thing Nokia did was sell all the handset division to Microsoft for $3 billion. Because that's allowed them to fund a lot of new stuff now. They've got refocused. So yeah, I think there's a lot more pain to go there, especially on the Ericsson side. I think Huawei's got a lot of pain to go. When I said that $2 ARPU number, or $2 cost per subscriber to build 5G, that assumes white box and all these things that are already happening. So actually, I'll give you another number. If you want to add 1 gigabyte of capacity to a 4G, to an LTE network today, costs you about $1.10, $1.20, right? Half of that cost is software upgrade. 5G in 2020 is going to be about 14 cents per gig. So move it forward down the cost curve. It's not today because obviously it's brand new networks, but down the cost curve it gets it. Whereas LTE took about 10 years to get to that cost curve, 5G will take 4 to 5 years. It's going much faster down the cost curve. 10 years time, 5G cost per gig will be, 10 cents, 15 cents.
Perfect. Appreciate that. Another follow-up question going a different direction, and that is the Internet of Things you talked about, right? And this river of pennies. And we have the narrowband IoT and different platforms there, and maybe the wideband. Can you describe the differences between those, where they're at today and where you see them in the future?
Yeah, so basically the difference is if you want to connect a video camera, right, to a wireless network, you've got to use LTE, okay? Because you need the bandwidth to get the signal through. If you want to connect a water meter, you're wasting a lot of money putting LTE on there. The cost of the device, the connection is way too big, and you're taking capacity from real users like my son. who is using your network on my dime. So what you do is you take a little piece of the network, narrow band, right? And this is the LTE-M for machine. There's also LTE-NB, and there's different, they've got actually different formats for different types of devices. One of them is data only, one can have voice with it, that type of thing. And basically you say, okay, water meter, I'm going to put your little LTE-M unit on there, small, cheap device, and you're going to send, what, a couple of bytes of data a day, right? Just ding, that's it. So that's what they're really for. You're not going to plug a video camera into it, it won't work. You're not going to give it to a teenager because it won't work. Put it on a dog collar, put it on a teenage collar. Put it in a car to track the car. Those types of things would work. So that's basically the difference. And the other answer, the question that usually comes up is that, well, what about companies like Sigfox, Ingenue, there's the whole LoRa guys, low radio, whatever it's, LoRa. Yeah, the problem they had is they tried to build proprietary networks for something that the big carriers could do a year later, because you guys were all waiting for the LTE standard, LTE-M narrowband. As soon as that was done, you rolled it out with a software upgrade. That's all it was. And suddenly Sigfox is sitting there going, oh, you mean nobody wants our proprietary network? So kind of wrong time to do that. So.
You mentioned LTE-M, right?
Yeah.
That's just a solution for machine to machine.
Yes.
And then I read something about 10-year batteries and that sort of thing. So does it require big innovation in terms of battery technology as well, or
no? It's think of it as the flashlight in your house. Everybody's got a flashlight in their house that's there for emergencies, right? It's usually right by the junction box for when the power goes out, right? Which is ironic because you've got to find the junction box in the dark to find the flashlight. Really, you should put the flashlight by your bed. Anyway, that flashlight, the batteries on that could last, what, 10 years, right? Because you turn it on once a year, okay? And actually, you could turn it on more than that. You maybe turn it on once a year for 10 minutes. But what if you turned it on once a day for a second? How long would the batteries last then? Same thing. So I could put a pretty okay-sized battery in a device and put it on a sprinkler head. It'll last 10 years because it's firing up once a day. Most of the battery life on your smartphone goes to the screen. Okay, the second hog in your device is the radio. And if the best way to extend your battery life on your phone is turn off Wi-Fi and turn off Bluetooth. Those are battery hogs. So if you don't turn them on, you don't use the battery. And that's what LTE-M does. Instead of assuming connection all the time, it just says, hey, I'm here. Here's what you need to know. I'm going to sleep now. That's it.
I heard Jeff say that the 5G handsets and whatever widgets we're going to use won't be backward compatible. So what's that mean? When 5G comes out, you got to throw away everything you're using today and buy all new stuff, or what?
Yeah.
Yeah.
It's called evolution. No, I mean that's what happened with 4G, right? We went from 3G. A 3G iPhone or Samsung smartphone wouldn't work with an LTE network, and then you guys rolled out 700 megahertz. That didn't work with the 850 devices. There's no backward compatibility. Same thing again.
Yeah, but they made it all work, right, in the handset.
Oh, it will work. Yeah.
And so is that what he was talking about?
Well,
the same thing, or
he's
something different?
He's actually, there's two things here. So one, and he did mention this. So if we're going to put 5G into 600 megahertz, you're doing 700, 850, PCS band, AWS band, 2.5 gig, all that stuff, then the changes to the phone are minimal. It's basically a new chipset. So I've got an iPhone 7. What are we on? iPhone 8 now? We're on 8?
10.
Yeah. 10. Well, 10's
If you get a good one.
10's the one that costs more than a car, right?
Yeah. Well,
Yeah. Let's call it.
a man that does what you do and you get cheap on the phone?
Yeah, I do.
Gosh.
Yeah. There's another reason, actually. I'll tell you one. So we're on the 8. The 8S will support 5G new radio. The 10X, the XS, will support 5G new radio because they're just going to plug in a chipset, make it available. Millimeter wave, right? That's different. That's the one where I need the 24 antennas and I've got to deal with my hand. That's the one that's going to be complete redesign. And reality is it's probably going to be in a tablet way before it's going to be in a smartphone because a tablet's got more area to hide stuff in, right? It's easier to build stuff in there. Yeah.
So what kind of devices are we going to have? We're still going to mostly have just iPhone type handsets.
Yeah.
Will it be? Do you expect to be a lot of innovation and other stuff that we'll have? Will we get a hole drilled in our head and
Well, some
just,
people probably
carry
need that
it
already,
around
but
in a hidden way or something, or what?
the smartphone fundamentally as a design has not changed since the iPhone came out. If you look at it, they're all shiny glass blocks, right? The tablet hasn't changed fundamentally since whatever the first tablets were, right? I think the iPad was on, but no, I'm not sure we're going to have a different form factor. I think you will see it built into TVs, right? So a TV today, a smart TV, has Wi-Fi built into it. It'll have 5G built into it. So you buy a TV, and then I just go on there and connect up to my T-Mobile, AT&T account, whatever, and it's got HD, 4K, 8K, straight to the home.
Talking about different devices, can you, in terms, HetNet and 5G and 4G, can you help explain those terms and compare and contrast?
Yeah. So 4G is fourth generation. We only came up with this for 3G, by the way, right? Then we went back and renamed our Gs, right? So it's kind of like redefining what high blood pressure is. They just changed the bar, right?
They change it all the time. They
do,
keep
don't
telling
they?
me, I have high blood pressure. No, now you don't have high blood pressure.
Yeah.
Then I have it again.
Yeah. If you move to the UK, you don't have high blood pressure because their bar is higher than the US, right? So that's what we did with the Gs. We kept 3G, then 4G was fourth generation, 5G is fifth generation, right? Normally we have a new air interface, as Jeff was saying this morning, but 5G doesn't. It's still the same OFDMA. Well, it's got tweaks to it. They've tweaked it. So that's and the next one will be 6G, and then I won't be here for 7. I'll be doing other things. Might not be here for 6. HetNet is architecture. So it's heterogeneous network. So that says I've got a combination of big cells, small cells, Wi-Fi, all glued together. It's heterogeneous. It's different types of networks glued together to give me one experience. So the best example of HetNet is macro cell and then small cells. That's a HetNet. Also, if we had Wi-Fi integration, right, where if you're on a Wi-Fi at the airport and you move outside, it hands off to LTE. Doesn't happen because of business terms. Technically, it can happen, but that would be a HetNet, heterogeneous network. So it's not. Yeah, so 5G integrated with Wi-Fi is HetNet. 5G with small cells and macro cells is HetNet. It's architectural. Yep.
And is that the most probable solution for all carriers to use multiple different functions?
Oh yeah, you are. Yeah. The problem you had with Wi-Fi, technically you can link Wi-Fi and LTE networks, so you and I wouldn't see a difference. The problem is the business terms, because like Boingo owns a lot of the Wi-Fi stuff, for example. You guys bought Wayport years ago to address this. But Boingo says, hey, I want to charge you 10 cents per megabyte. And you guys say, no way, give you, and that's the problem. The other problem is people like me turn off Wi-Fi on their phone. And you can't remotely turn Wi-Fi on the phone. You can't do it remotely.
I'm going to see if I can get you to help me make some of my arguments for me, right? So lots of technology change going on, right?
Yeah.
And so we have people looking at valuing this equipment on, say, a 10-year life. So they go out to a macro cell and they look up at an antenna and they say, boy, all antennas last a long time. They put it on a 10-year life. And I tell them, my guys tell me 3, and we might have change outs before then. Could you talk a little bit about the different categories of equipment and how rapidly we'll see this technology change over time and the equipment change out?
Yeah. I'm going to answer your question, but I'm going to get something complete. Has
You gonna
anybody
hedge-
seen-
you gonna hedge
has
on me?
Yeah. No. Has anybody seen the David Letterman interview with Obama on Netflix? Yeah. And Obama picks on him for his having his big white bushy beard. He looks like, I was just sitting here looking at it thinking, man, it just reminded me of David Letterman. I don't know why. Anyway,
I don't know how to take that in.
well,
Thank you.
go watch Netflix and I'll tell you, my wife said, he does not look good with that beard. He needs to have a shave.
Yeah, that's what my girlfriend tells me about this one.
So, okay, way back when we had 3G, right, we put up an antenna and it lasted 10 years, right? And then what happened was the cell tower guys said, yeah, we're not going to just charge you per box. We're going to charge you per band, right? And per box. So what we had was remote radio heads. And remote radio head, they came for LTE, little pizza-sized boxes. They go up on the antenna, up on the tower next to the antenna, about 18 inches away. So now we have more boxes up on the tower. So Crown Castle, American Tower and Company charge you more money, right?
Right.
So you guys went, hang on a second, we'll get smart here. What we'll do is we've got 2 antennas up there. We'll take them down and put one up that combines both of the antennas in one box. So, got you, Crown Castle, right? And then Crown said, yeah, but that box is doing 700 megahertz and 850, so I'm going to charge you for that, right? So this backward and forward has happened as from business terms. At the same time, you guys have just bought 600 megahertz. You bought quite a bit, $20 billion worth of AWS-3. Next up is the CBRS band that Jeffrey mentioned this morning, 3.5 gig. That's going to go on a tower and other places. So if we put up a new antenna every time you had a new band, the tower would fall over when the wind blew, right? Physically, forget the business terms. Physically, it'll fall over. So we have to integrate more of those antennas into single boxes. And the antenna designs that you guys buy are actually specific to you. So you're building FirstNet, right?
Right.
There's actually 8 to 10 different antenna designs for FirstNet, depending on what other frequencies are used on that macro tower for the different markets. Okay, you're doing the same thing with 600 megahertz because you've got different combinations, right? So the life now, you're putting out FirstNet. You may be replacing an antenna that's a year old or 2 years old.
That's what I keep trying to tell people.
Yeah, it's true.
They don't believe me, but I keep telling
They're
them.
going to find out pretty fast here. And so the average life of an antenna was 10 years, then it's 5. Today, it's around 2 to 3 years. We're going to have more auctions, right? You guys have been asking for millimeter wave auctions, and there's that unlicensed band at 5.9 gig, et cetera, et cetera, et cetera. If you had purchased Sprint, you would have been buying all new antennas to increase their 2.5 gig and everything else. So when somebody buys Sprint or Sprint falls apart, you buy all that, whatever happens, right? Then all these things affect it. One final thing. Jeffrey mentioned massive MIMO, right?
Yeah, that was my next subject.
Yeah. So this is 64 antennas in one array. They can be, there's different sizes, but they can be like, like this big, right? And they're all little antennas, 8 by 8, right? Each of those little antennas, you can't have a coax coming off of it to a radio, right? Because the tower will fall over. Think of the weight of 64 coaxes. I mean, it won't work. So what they do is they put the radio, actually glue it onto the back of the antenna, right? So the antenna's on the front and there's a little radio right on the back. And then all the circuitry is into the antenna. So the panel, you'll see some that are deployed, they're like big panels, and they're about that thick. And all the radios in there with the coax port connections, the fiber connections into them. Guess what? You do massive MIMO, you're going to rip down everything on that tower, or some of it, and push up this stuff, including the remote radio heads, which you've just paid for. So if you start deploying massive MIMO, absolutely, that current equipment, some of it's redundant. Yeah.
So when you talk about massive MIMO, Is that something we'll deploy most everywhere, or just in densely populated
There-
areas? Or
So MIMO is multiple input, multiple output, right? So the multiple being more than one, right? So you can put up 2x2 MIMO, and Verizon's doing this already. You've done a lot. You're doing, I think your 600 meg is doing a lot of it as well. 2x2 MIMO is going to be pretty much everywhere, certainly up and down I-35, any metro market. Get out in West Texas, the cows don't need it, but right. 4x4, now we're getting into some dense suburban areas. Maybe there's a shopping mall there, that type of thing. 8x8, now we're in downtown areas. 64x60, 128 is the next one, whatever that combination is. Now you're in like 2nd Street, 6th Street, very dense urban areas. So think of MIMO as proportional to the population density, right? Yep. But again, all of that ages your current equipment. You put up 2x2 MIMO as a basic antenna, it's going to make your stuff redundant. So, depreciation cycles of 10 years are probably a little ambitious.
yeah, we have a few that are a bit longer than 10 even. So, but we try.
And maybe this is a good spot to stop and take a question or two from the audience and wrap up this great fireside chat.
Because the fire's nearly burnt out.
Yeah.
As the fire is going, do we have any follow-up questions for Iain?
Wow, jeez. Nobody asked about autonomous driving. That usually comes up.
I had it on my list. I just haven't gotten to it yet. So, just to touch on that, the guy for AT&T that's responsible for the technology and all the cell sites in the middle of the country, I call him up every once in a while to get the real story. And he'd just come back from a conference someplace, and he said, a lot of technology out there they're talking about, but I believe autonomous cars is only just a very, very few years away, and that we'll see it quickly. What's your thought?
I'll answer it this way. I have a bet with a friend of mine. We were sitting last June on 2nd Street down here at the JW Marriott, having a drink in on the corner bar there. And Kevin's like, man, it'd be great. In a few years' time, I'm going to be able to take out my phone, push a button on my car, I'll drive up to the curb, I'll get in the back seat, it'll drive me home to North Austin. I'm like, no way. And he said, absolutely way. This guy runs call centers, by the way, right? He knows nothing about this stuff. So we had a bet, 10 years, and we have an email that's dated, and there's a good steak dinner for wives with wine on it, that in 10 years' time, the car, he pushes a button, the car pulls up, he gets in the back seat drunk, and it drives him home to North Austin. No way. No way. There will be autonomous vehicles running around downtown Austin on predetermined routes. So shuttle bus goes from this hotel convention center, it does the same thing all the time. That will be probably within 5 years, right? Driving down the highway, keeping a fixed distance from the car in front, steering around corners, level 2, you can do that today, right?
So you think we'll have big over-the-road trucks using autonomous technology for that?
I think the liability on that, there's lawyers that sit there saying, please do that, because then I can sue Intel and Microsoft and Amazon as well as, sue the haulage company. Yeah,
else,
yeah. No, I think there's going to be certain things like autonomous braking, right? That's easy to do, and that's in a lot of cars today. We'll have more of that type of stuff. But actually getting, and then campus environment, like UT, it's pretty well known what's there, and it's a very low trafficked area. But there's a Tesla the other day ran into the back of a fire truck. Fire truck was stopped on the guy ran straight in the back of it because he's on his autopilot. I'm like, did you not see it? I guess he didn't. But okay, that's pretty basic, Funny story, somebody is developing autonomous driving software in Moscow. Why? Because Moscow traffic, if you've ever seen it, is the worst. I mean, they drive on the sidewalk. They said, if you can deal with Moscow, you can deal with anywhere in the world. They said the problem is not Google's campus in LA or Silicon Valley. That's easy, right? It's the unexpected that's the problem. So I think it's going to be a while. And you don't need wireless networks for autonomous vehicles. They've got to be able to deal with it on their own, right? they're going to need a connection for map updates and things like this. But if they lose a connection, the vehicle has got to be able to process on its own. Otherwise, it's going to run into a wall and say, sorry, you didn't pay your LTE bill.
The stuff I was reading about autonomous cars, they talked about they'd be able to kind of connect a whole bunch of cars that you could actually, the equipment could actually anticipate what's around the corner.
Oh, yeah.
Beyond what you could see, because it would essentially connect.
Yeah, so it's
everything
called
around it.
DSRC, or vehicle-to-vehicle communications. There's C, VTX is another one. There's all these different standards. So the car ahead basically tells the cars behind, hey, there's an accident up here, or there's ice on the road. Problem is there's no standards. So the Fords can tell the Fords, and the Chevys will tell the Chevys, and nobody will tell a Lexus driver.
That's fair.
On that note, we'll go ahead and wrap this conversation up. Iain, thank you very much for being
Thank
here.
you.